Hey, welcome back. I know we went sideways and did a lot of things in iOS app architecture while I was really interested in the Mojo programming language. So today we're going to jump back into Mojo. Okay, guys, so Mojo programming language. Basically, it is a language for uh, I guess data scientists. It's like Python optimized for performance plus performance plus it's more I guess it is more opinionated in certain ways. Plus, what it does out of the box is it actually gives you, capabilities to accelerate on hardware for vectorization, parallelization. So what that means is that if you wanted to do a lot of batch data processing, you can do it out of the box with Mojo. Now, previous setup took like a lot of time, but since then I think the website's been fixed. It's easier to jump on and know exactly what to do straight away. So we will just jump back in. We'll run an update. I think I wanted to do some loading. I want to see if I can get a CSV file loaded, see how that goes. How do I open a file with a CSV? We'll just have a basic data set, some random numbers and export that as a CSV and do some data analysis on it, maybe some regression or classification. Possibly. We'll have a look, see what the tools are. We'll go through it and we'll explore Mojo again. Okay, guys, let's dive straight back into Mojo. All right, here I am back. Hey, hope you're doing all right there. So we've just gone through and installed the updated version of Modular, which is the platform for Mojo, and also installed the latest version of Mojo. So basically, what we can do now is we can probably close this terminal. Maybe not close it. We'll just move this out of the way, and we're going to jump back into Mojo. So as I mentioned, I wanted to maybe generate some data or open a CSV file. So basically, we can do some data to generate data, save it as a CSV, and then let's try that. Let's just see if we can generate some data and save it to a CSV first. I've got some documents open we've got our modules here. Basically, we also have the standard syntax for functions and variables and structs. So I think functions pretty straightforward. Let's jump onto that. We want to just we've got our main function here, which runs. We've got, we're going to do it straight out of the box. We're going to do it straight like, just straight up, straight up fresh, absolutely no knowledge of the language. So apparently, there's def functions which don't need parameter name types, but that then, don't need them. But then there's functions which you do need the type definition. So we're just going to do an fn, right? We're going to do an fn, open CS. Oh, actually, create data. So this will, it's going to create. How do we do arrays of int? Does that work? And then we have that array of int. That doesn't like that. Expected a type, not a value. So let's see. How do we do variables arrays? Let's see. An integer array, lexical scopes. So well, okay, how do we, for parallelization, I think it would have been good here to actually be really clear with how do we create large data sets. If it's, that seems like it would be important key. Okay, maybe int like this, syntax, int. Okay, that looks like it, what's the return type? How do we do returns, functions? See, it's the same thing, right? So you just return, we'll do an empty array, like that. But does it work? No, doesn't like that. Unexpected token in expression. Ah, okay. We don't actually have braces. We have what looks like in the same. Okay, so that would initialize them to. It cannot implicitly convert int into type of int in return. Did you mean int? No, I think the parsing here isn't 100%, right? So you can do kind of like pointers, in-out parameters. Well, it's not supported yet for in-outs. Okay, so what we want to do is we want to create some data. And well, can we do, let's see, we want to create a variable. So our syntax for variables, and we have var and, let's see, var, do we have a constant? That is var. It's not like this. Okay, let's see. Variable var array of int that turn array. That work? Oh, it doesn't like it because it's not initialized. Okay, equals. How do we initial equals 1, 1, 2? That work? No. A list. Okay, we can create a list. We need a type. T. Okay. Let's have int equals 1, 2. So that's how we create. What? Can I just convert list literal in int value into list int? It's definitely I don't know, real problem. How to initialize an array. See, this is where, for when I switch languages, normally I would use something like ChatGPT just to click things as a refresher instead of trying to find things in the documentation. So we have variable structs, value semantics. So it doesn't really, like, we have variables, but it doesn't have lists. Let's see, we have modules, and do we have lists here? Built in? No, there's nothing really obvious here. Base 64 provides functions for base 64 encoded strings. Return a string that returns a string that's base 64 encoded. Algorithm collections. Here we go. This is what we want. List. How do we use list? Data fields. Collection type. The underlying storage for the list in out self. So this is the initializer. We have arguments, capacity. So is there any examples of initializing a simple array or a list? See, this is what I mean. Like, all I'm asking for is just a simple example. The list type is a dynamically allocated list from collections. From collections import list. All right. And we go, we do list in out empty list. So it doesn't like an empty list. Can we do, we have to do an int like this? No, that doesn't work either. The list type is a dynamically allocated list. It supports pushing and popping. Parameters. Oh, maybe I just do this. It doesn't like the from. Crash happened in the MOJO parser with the current version of this file. Damn. So we're not going to get anywhere here. Seriously. This is ridiculous. I mean, that's not ridiculous. I mean, what do you expect? It's a beta language, right? So we want to create a list. Literal. The type of a literal list. The list consists of 0 or more values. Okay, so we list literal. One, maybe we pass in the list literal's vertic arguments here. Oh, no. No, it really collection on. So we have T collection on the type of the elements, right? Data, underlying fields. Okay, great. So we have init, which we just do init with a self. Construct an empty list. So list dot init in out self. Oh, this looks like it's built-in underlying constructor. Which means you can't actually call it directly. A list like this, no. Just like this, no. Int Okay, there we go. We initialize the list. And here we have a list. Okay, so what are the square brackets? We create a list. We got there eventually, right? So we initialize the list. It looks like the template type is defined in square brackets. It's not really clear how that works here, but with the documentation, I mean, really, append in itself. This documentation looks like auto-generated. There's absolutely no examples. So look, I guess this is part of the learning process with a new language. I mean, we're getting here on the ground floor, right? So we create a list, and then can we do like in our I in 0 to 1,000. Do that? Does that work? This is like Swift syntax, right? No. How do we do expected name in attribute float literal? Okay, so let's have a look at how we would do traits, Python, tools, project. There's no. So we're getting an introduction, right? But there doesn't seem to be much information as to structs, traits. How about iteration? Repeat, function repeat, for I in range. Aha, there we go. I mean, look, I remember when I was looking at the Swift code. Oh, that reference manual is one hell of a reference manual. For I in range of 1,000. And then what? I think it's like this, right? It would be, well, it should be like that. For I in range of 1,000. All right. Repeat count in square message string. That's interesting. What is in MOJO, a parameter is a compile time variable that becomes a runtime constant. Many other languages use parameter and argument interchangeably. So be aware that when we say things like parameter and parametric function, we're talking about these compile time. Oh, that's interesting. So we have, in order to improve performance, we have compile time parameters. We also have runtime parameters. So compile time parameters, obviously here we can specify the count here for repeat 3 times hello, right? This function has a parameter type of int and one argument. Oh, that's interesting. That's very interesting. Is a complex topic that is covered much more detail in the metaprogramming section. I don't know what it is, but I am actually really liking this. This is pretty cool. I think this could be something. This could be something. There's just little things that are piquing my interest. Parameterization, parameterization. That's it. By specific count. All right, blocks and statements. Def loop, for x in range 5. Code blocks such as functions, conditions, and loops are defined with a colon. We have an fn create list, create data, and let's just say, amount int, right? So we're passing the amount int, and we'll just go amount. We'll do a range like this. All right. And I guess this is the great thing, right? So what will happen if you had this as a parameter as opposed to an argument, then it would optimize it, right? So you could have the compiler optimize it. Here it doesn't do anything. For I in range, what's it complaining about? Expected body. It expected a body. Have a disembodied for loop. Anyway, all right. So we have for I in range, and we'll go our list. What are we calling it? Array? It's not an array. It's a list. Let's call it generated list. Generated list. So really simple stuff here. Generated list dot append. So I'm glad we don't have this mutable and non-mutable stuff like you have in Kotlin, which just gets out of hand. Append. Let's see. Like, can we get a random from? What about if we do print? A string. Create. How do we do create data? 1,000. I don't know how that works. That's definitely like that's how I would have thought it would be Python-esque. Python-esque is like this. No, I think it's actually like this. How does it work in Python? Well, anyway, we will get to that in a bit. Let's append a random value. Let's go see if we can find in our modular docs. It'll be under math probably. No, it'll be under random. Yeah, random. Random provides a function for random numbers. Well, we don't know about C. We just random float random UI in 64. Okay, that's what we want. Random. Oh, we're random int, right? So import. Where do we get random from? Random import from random import seed. And here we go random float. I guess from random import star. From random import star. Does that work? Maybe. Let's see. Random signed. We just okay. Random dot rand int. How cool is that? We just got rand int. Why isn't it like that? Invalid call to rand int missing 4 required positional arguments. Oh my god. Fills memory with uniform random in range. That's pretty cool. So this is optimized just to pump a depointer. Depointer size low high. Right. So this kind of like does it for us. Do I care right now, or do I just want to figure out the basics? I don't care right now. I just want to figure out the basics. So that we don't really want that. What else do we have? Rand is, can I just rand fills memory. Okay, what about these? Rand int, rand n fills memory, rand float returns a random double sampled, random signed in 64, random. Well, this no, it won't work because we don't have lists. Yeah, min max min 0 10,000. Method argue converts from DSI to int. Okay, so it's returning something. It's returning a SIMD to int. Let's try that. Oh, nice. So what is returning? It's returns a random number from the specified range, but it's SIMD SI64. What it looks like it's some kind of integer representation signed. Returns a random number from the specified range. Rand int. It fills memory with random values from a uniform distribution. So what a deep pointer is. Okay, so we're kind of like exploring mean variance. Oh, this is pretty cool. So see how it kind of fits in with data science, right? You generate data across the distribution with a mean variance, normal distribution variance, normal distribution mean. All right, that makes sense. So there's a lot of kind of statistics and probability math that would be good to refresh up on. We have sys. And we have, do we have FFI, implements foreign function interface? No. We want a pathlib. Okay, path implements path-related functions. We want an IO utils. Loop index inline implements higher order functions. Decorators, static method. Cool, nice. Let's see, we have a buffer here. A list. Okay, what else do we need? We need some IO OS. That's what we need. We need pathlib file. Come on. Implements the OS package operating system. Atomic class implements basic routines for working with the OS environment. Here we go. Set and no, that's the environment, not the actual path, maybe path. Will this give us path files? Is dir, is file. Okay, is link? Yeah, no exists. L exists. Do we have a winner? Do we have something that can give us a file? Built in. All right. Built in file. There we go. We got ourselves a file. This is it. You're getting started when you can open a file. Yep. I love it. New language. I remember I was like with the first time that I did Swift back in like 2014. Building view controllers in Swift was just like syntax, but this is like low level. This is like learning, C again. You've got the basic top concepts, but you got to refresh your syntax and just sort of get started in the syntax, right? So it's just learning a new tool. So we have var new list. Can we do this? Create data 5,000. So amount, I'd say max. Just go max. No, look in. We're just a experiment max. So we're just working with ints. Let's fix our syntax. Let's fix our formatting. The kind of like the nicer way of doing things. It really should just bounce back. All right. Great data. Min max. So we've got min 10, max 100,000. New list. And then we go min, and then max. All right, there we go. So we've got our list. All right, if we just Mojo. Let's see, Mojo. Do we have Mojo? Mojo build hello Mojo. Okay, Mojo. We'll do. Okay, we'll do this. We'll see if we can we print new list. No, it's not gonna like that because it's gonna expect a string. I wonder if this book we do list reserve resize reverse pinned. Interesting. Do we have string functions? File hash in literal string. Here we go. In out we can append a buff list in 8. Okay. Constructs a string from a buffer of bytes. Nice. And you always need that. In our case, what I want to do is I just want to take each number and, in the list. Well, how would we do that? All right. So let's see. We go for item in new list. Does that work? Okay. Print. And we maybe print item. What can we do with it? That's the value. String print. I think we can find something here. Print benchmark. Print IO. String literal. Print separated string literal and literal flush. I don't know what these mean. First, second. This is IO provides utilities for working with input output. We want to find again. I have to say the actual website and the help search for this is really fast. Print host hardware information. What about this one? Self-label string. So here we are in graphs. This is like where we're kind of diving in pretty far here. Print. Essentially, I just want to print the value, and I want to see what the string insertion. How do we insert string here? Is it the same as Swift? No. Is it? How do we do it? Overview, guides, examples. Llama 2 diction. Okay, Llama 2 text generation. Okay, let's just dive right into it. Okay. So a lot, this is probably deeper than I was expecting to go, because I'm just showing how the process of you know exploring the basics of a new language, and trying to get your head around how things might be implemented. So I mean, this has been around for a while. You can see getting started here with a llama. I mean, this is really, really huge. This is not simple stuff. We've got, this is something that's been worked on for a while, and it's been done by someone who's an expert in this language. And basically, I'm just getting in on the ground floor. I have no idea how the syntax works. I have no idea how a lot of this stuff works. So it's good to kind of look at this to see what else you might kind of spot. But it can easily get a bit over the top. You get lost in the code here. So we're going to jump back, and we could jump into this llama to maybe examples. Let's look at this. Tools, performance showcase, graph API, inference. Really, it's just let's have a look. This console, this is like Python, inference models, notebooks. This is way too max. This will modular max. Collection of samples, notebooks, and tools which highlight the power of the Max platform. See, again, too much, too far. This is Llama 2 text generation. It's Max Graph API with MOJO, MOJO API with TensorFlow. All right, text prediction, C API with TensorFlow. We have, see, BERT Torch script, Roberta TensorFlow. I mean, this is text to image. What am I looking for here? I'm looking for something just to simply inject text. There's a comment here. Concatenate tensors AB. Okay, what does that do? Interesting. Mem copy. So there's a lot of, this is definitely a lot lower level. You can copy directly between memory from one point to the next. Obviously here we go. We've got 4i and range, the basic stuff here. We've got math generation functions, but still, I don't see anything that just tells me how I inject text into. Here we go, var usage. Here we go. No, that's the text to image usage. Raise error, set environment. Come on, how do I plug in? I'm gonna do item value equals plus item. No, to string. What if I do string? And I do string new list. No, it's not gonna like that. So kind of like I'm poking around in the dark here, right? And I'm looking for something which will give me some insight. Print usage. I don't see anything here, right? We've got a lot of cool stuff here. Print loading models, great, that's awesome. But where do we inject text from a value into a string? It's not that, it shouldn't be that hard. Here we go. All right. Generating image, I+1. So we've got print R. What is this? What is this? Okay. Comma. Okay. I think we got it. We got it. It should just be item. Is this going to give us? Oh, no. That's not fair. No matching function to call print. That's not right. What are you talking about? Is it dash R maybe? What is this? Dash R / R. No, that's just a. What function is this print? What print is this? Import sys, import random, import sys. Come on, where is this function? Where is this print? Import Python utils. Python utils? Oh, that's not it. Math. Come on. What is it doing here? What have you done? does this mean it's not going to work? Print end equals, this just doesn't make sense. So we go, what is it? I equals item plus 1. Reference int one new list does not implement add method. Oh, what is this? This should be an dot value. Okay. Oh, come on. Surely this should be just an int. This is a list of ints. What is this? This isn't an int. It's an item reference int one list. Dot value dot what? For I in range of. I mean, seriously, range of num time steps. I've got a new list, a list of ints. List dot, what is this? Can I actually data? So that's the size. What about if I just do range? I'm kind of really just plugging the duck here, just to come on. This is gonna be easier. An easy way. How do I pull out an int from a list? Num time steps. I've got a value of int, but I have a new list, right? So new list, item in new list, and we have item dot what? It's come on, it's got to be. No, I don't want item dot the type tells us the type, bit case cast element, offset, the integer offset the reference like an array. The underlying MLIR value. I mean, come on, how do I get a value for I in range? Alpha's time steps I, 2 float. Okay, maybe 2 int, to the value dot 2 int value dot maybe value dot 2 int. Come on, what is that? I mean, just to, I just want to make an int. All right. You know what? This just 2 int. It's a function value 2 int. Item dot. What about if I do 2 int like this? That's not going to work. No. Dot value. And what's the error that it comes up with? MLIR has no attributes. So we don't have a value. We could possibly do 2 item 2 int. Reference. Maybe we go here 0. Is that 0? Item 0. 2 int. Dot. This makes no sense. I mean, 0. Oh, okay. There we go. I did it. I have no idea what I did, but that's it. Let's just see if we can just number and see if that works. Number, and then we do that, and we go. So we need end. Do that. We do new line. Surely that work. All right, let's just build it. Hold up, MOJO. Oh, okay, built. So let's do hello. We should have hello. Yes, there we go. We figured it out. I mean, that's just chance. Some of these just, I remember the first time, God damn it, writing a linked list at the age of 14 in C, trying to figure out what a pointer is. I was just sitting there, just racking my brain for weeks, trying to figure out how to build a linked list going back and forth. But once I got it, that was it. And just that was like learn C in 21 days. But there's no learn Mojo in 21 days yet. Hey, that sounds like a it sounds like a job for somebody. Well, guys, I've got this. I mean, we've got a basic loop. We've got a generated list, basically without any assistance from Stack Overflow. And just looking through the example code that's provided, there's definitely a lot of room for improvement with there's a reference with the guides. I think this is something that I want to dive into. I'm gonna basically dive into this at another pace, going through the Max engine altogether. So we've done some Mojo, and we're going to look next week at Max, at what that is and how that works. So, guys, thank you very much for sticking around and plugging away at our first little experiment. It's like learning to walk. So, guys, thanks. I will catch you at the next video, and we'll go and explore Max. Bye.